Hi everyone, it's Coach Fred here, and today I'm going to be doing a review of factoring polynomials. And in the last video, I did a quick review of multiplying polynomials. Some of you may remember it in many different ways. I know that there are some people out there that use the word FOIL. Not a fan, but it's okay if that's the only way you remember it. But basically, you're going to multiply these two polynomials together, and I'm not reviewing that right now. This is actually going to work out to x squared minus x minus 6. All right, because the goal today is to talk about factoring. So we actually did this. We multiplied to get this. And now we're kind of going to undo that and go backwards to break it up into a product. So we're reviewing factoring. And again, it's just the opposite of multiplying. So we're going to figure out how to undo polynomials, trinomials, binomials, and polynomials and break them into their factors using multiplication, okay? We're going to need this because eventually we're going to be solving equations. So let's just remember that these are expressions, so we can't solve them. All right, so today we're going to talk about factoring, and we're going to look at one special factor pattern. Now, when you learned about factoring, I'm hoping that your teachers gave you kind of a process to follow. Now, they might have added different words or different terminology, but the basics are, number one, that's why it's in red, step one, you always want to factor out a greatest common factor if there is one. I like to call it GCF in it, okay? Then you look for how many terms the polynomials has. So either 2 terms, 3 terms, or 4 terms. Those are the only ones we're going to worry about right now, okay? And then once you look for the 2 terms, 3 terms, 4 terms, we're going to learn different patterns there may be or different processes we can follow. And then you make sure you factored it completely because sometimes once you factor, you might have to do a little more to it. All right, so today we're going to look at 2 terms. So the first thing that I always want to look for with 2 terms is called the difference of 2 squares. I shorten it and I call it dots. I always like having a fun name to call things, okay? And the difference of 2 squares means the difference of 2 perfect squares, okay? So anything that is raised to the 2 power is a perfect square. So x squared is a perfect square. 25 can be written as 5 squared, so it's a perfect square. So when we have 2 terms, so in this case I have 2 terms, both of which are perfect squares, well, there's a factor pattern that develops, okay? And that factor pattern is you have 2 binomials. The first term is always the square root of the first term. The last term is always the square root of the last term. And we have 1 negative sign and 1 positive sign. So as a reminder, this is how you use it. You first look at how many terms they have. There's 2. I see if there's a greatest common factor, which there is not, besides 1. And I notice they're both perfect squares. So I can factor this into 2 binomials, taking the square root of each term, x and x, 8 and 8, and then 1 plus, 1 minus. It's as easy as that. All right, this one's a little bit more challenging only because I put a number in front of the x squared, but I look for a greatest common factor. I don't see one. So then I check to see if it's dots. Perfect square, perfect square, perfect square, and they're being subtracted. There's no such thing as the sum of squares. That's important for me to mention as well. No such thing. Okay, so I factor it. 2 binomials, square root of the first term, square root of the last term. So 2x, 2x, 5 and 5, and plus and minus. Now you might say, could I do minus plus? Yes, that doesn't matter. The commutative property of multiplication allows you to do either. All right, let's look at a harder one. You gotta always check to see if there's a GCF first. And in this case, I have one. And I would have thought about that because it is 2 terms, but they're not perfect squares. But when I factor out the greatest common factor of a 3, I'll be left with 4x squared minus 1. Okay, so we factor out the GCF. Then we look to see if this is a special pattern because it's 2 terms. 4 is a perfect square, x squared is a perfect square, and yes, 1 is a perfect square because 1 times 1 is 1. 1 squared equals 1. All right, so we're going to keep that 3 because that GCF is part of our answer. and then 2x plus 1, 2x minus 1. All right, and that's the difference of squares. So now you're going to try the problems that are assigned after this for practice. Have a great day.